Today we're going to take a look at transformations of functions. So in your notebook, label your table of contents. Oops, sorry about that. And then open a new page. And you can write on there, this is looking awfully messy here, transformation of functions. And then the first thing you're going to do is, in your notebook, you are going to paste our parent functions. And you probably will remember these from last year. We have a constant identity, the x squared, x cubed, square root of x, the absolute value of x, which you can't see here. It did not upload here very well, but there should be absolute value signs around there, and then 1 over x. And underneath that you have all sorts of different graphs. So what your job is to do is to cut and paste these and see if you remember which parent function is what. And you'll notice on here this is an extra one. We aren't going to go over that one, so you won't be using that one. So let's see. Let's see, that's our absolute value function. So we can put that right in here. Let's see what our next one is. Well, I know this one has some asymptotes, so that's got to be 1 over x. Let's see. This is the line y equals x. What else do we have down here? This next one, this is the square root of x. We just have a couple left here. Hopefully we recognize this one is our parabola. So that is our, whoops, x squared let's see, this one, between the two, the last two, this one must be x cubed. So our last one, y equals 0, that constant, so that would be this one. And so what we're going to talk about is transformations of these. So on the next page, in your notebook, you are going to paste the foldable in there. And most of this you guys probably remember from last year. We have reflections and translations and dilations. And we're going to take a look at it in function notation this year. So underneath these flaps, we have these reflections and that kind of stuff. We're going to be drawing a couple of graphs. But at the top of this, at the top of the page, before you paste that in there, what I want you to write is f of x. And then underneath that, let's see, I want this to line up on these axes. Let's see if I can. That's a little bit better. We are going to draw an f of x graph. And then if we want, just so we can see some of these coordinates, we could label a couple coordinates on there. So we could label this as 1, 1, 2, 0, and 1, 2, 3, 2. And then we still have 0, 0. So what we're going to do is, underneath these flaps, we're going to draw some transformations. So back up to this top flap, these reflections. We have negative f of x, so the opposite of f of x, the opposite of y. Well, our opposite y value would flip it down, so this is opposite y, which would make it a reflection across the x-axis. So when you see this next one, f of negative x opposite x, well, if here's x, that's going to flip it over here, the opposite of x, so this is a reflection across the y-axis. And you can write those right on the flaps, and then underneath this, we're going to go back down here. So underneath your reflection, we're going to see what this looks like here. So we'll draw another little grid. So if we reflected f of x, it would go down, down like this. So this is opposite y, so this is negative f of x. And if we did the opposite x, it would go this way. So this is f of negative x. And you can look at those coordinates. So this is now negative 3, 2. So the opposite of our x value, negative 2, 0, negative 1, negative, positive 1, excuse me. And here we have 1, negative 1, 2, 0, and 3, negative 2. So it's our opposite y values. So the next one's up here. I am guessing that you guys, these are probably the ones you remember the most. If we take something and add c, this moves it up c. This one moves it down. And these are kind of like if we had, you know, x squared plus 2. Or if you had f of x equals x squared minus 2. It moves it up and down. And then the second set of translations, right and left. So this is like if we had f of x equals x plus 2 in parentheses squared. Well, what does the plus 2 do? It moves it to the left 2. And if we had the subtraction, that would move it to the right 2. So underneath that first translation flap, let's see here. If we were to graph f of x plus 1, and I'm going to redo this axis here. That would move it up 1. And if we were to move f of x minus 1, it would move that original function down 1. And then that second translation, that left and right, if we were to move it over 1, so this would be f of x minus 1. And let's say we wanted to move it back here. Well, how far back did we move it? 1, 2, 3. So this is going to be f of x plus 3. Now the last two we're going to take a look at, these are probably the hardest ones to remember, the scale factor. So on this one, you can see that we're multiplying our y, the whole function, by c. So this is kind of like saying if we did y equals 2x squared or y equals 1/2 x squared, you multiply the y values by your scale factor of c. So a lot of times you call these vertical stretches and compressions. So if we go back down here and take a look underneath that flap for dilations, so let's say we had 2 times f of x. I'm going to dash in the original here. So here's our f of x. And if we're going to multiply each of those values by 2, 0, 0 stays at 2. But this one, the height doubles, so it goes up here. This one, the height doubles. Well, it stays the same. And this one, the height doubles, so it's at 2, so it would go up to 4. So there's that one there. And again, you can look at those coordinates. 1, 1 became 1, 2. And 2, 2 became 2, 4. So that y value is doubling. Where if we had 1/2 f of x, what would happen is our heights would go to half. So it would go here, 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 and then here again. So we're going half of those y values. And then the last dilation we have here, you'll notice these are next to the x. So this is kind of like y equals 2x squared, or y equals 1/2 x squared. And these are our horizontal stretches and compressions. So these, our scale factor though, is 1 over c. And that does not say 1 over c, excuse me, 1 over c. And so this is where we multiply our x values by that. So if we go back down here to our dilations once again, that last one, and maybe we'll draw it on 2 separate graphs, this one, so it sticks out a little bit more. If we had f of 2x versus f of 1/2 x. And again, our original was right here. But our x values in this one, it's going to be a scale factor of 1 over 2. So we're basically taking half of our x values. So it would become here. This one was at 2, so that it goes back to 1. 1, 2, 3. So it goes back to 1.5. And we have a horizontal compression. Whereas this one, our scale factor is 1 over 1/2, which equals 2. So we're doubling our x values. So 1, 1, so it goes to 2, 1. 2 goes to 4, and 3 would go to 6, which is a little bit off this chart, so way over there. So now what we're going to do is we are going to take a look at, let's say, we're going to look at an example here. Let's say we have f of x, a graph. Whoops, sorry guys. And our f of x, maybe our f of x looks like this. And I ask you to graph f of x minus 3 plus 2. Well, what are those transformations? Well, the plus 2 goes up 2, minus 3 goes to the right 3. So then we'll take each of these coordinates, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and we'll move it to the right 3. And now let's say we had graph 2 f of x, maybe negative 2 f of x. So this reflects the negative, and then the y value times 2. So 0, 0 is going to stay, but this one is at negative 2, so it's going to reflect a positive, and it doubles, so it would go up to there. 0, 0 would stay, and 1, 1 reflects but doubles, so it goes up to here. So it would look like that.